Protecting Private Cloud Data with Data Protection Manager 2012. So this is the fourth of our four-part series on the other bits in System Center. And after that last nugget, it's almost sort of anticlimactic to move over to Data Protection Manager. Backups and recovery have been for a very long time in IT one of those, I don't know, one of those not terribly exciting activities. You know, it's a very important activity. In fact, your business would probably argue that the backup and recovery activity is one of the most important ones out there. But compared to all the neat stuff that we saw back in Service Manager and also in Orchestrator, well, it's just backup and recovery. Well, the good news is that Microsoft has put forth quite a bit of effort in the new features that exist here with Data Protection Manager 2012. Previous versions tended to be one of those kind of applications that you really wished was more exciting than what it was, or that it had some features that you just knew should have been there but didn't really exist. DPM 2012 kind of overcomes some of that expectation management, and I think you'll be excited to see some of the new features that exist in DPM 2012. I'm going to show you just the very, very basics of DPM 2012. You're going to get, for the exam, just a couple of questions, a handful at most, on what you need to know here as it relates to private cloud. But I just want to show you kind of some of the basic workflow that you'll go through for preparing disks for DPM, configuring auto discovery, which is a useful thing, especially in a very dynamic private cloud environment, installing agents, creating protection groups, and then going through those steps of backup, recovery, and reporting. So all of these are things we're going to do here in the interaction portion. This will be a relatively short nugget, I think, which you're welcome. The last couple have been quite a bit longer than even I expected. So let's spend just a minute taking a look at the different pieces that exist in DPM 2012, and I'll show you the ones to be just prepared for, and also the ones that, well, you'll see a few items in there that may make you shrug your head a little bit. Well, why do these actually exist in this interface in so many locations? So here I am on client.company.pri. This is our little workstation computer that has all of our tools on it. And I'm taking a look now at the DPM Administration Console. So I've done a few things here just to kind of get things started so you can see what a populated DPM instance looks like. One of the first things I've done here is added a disk. And so we have plugged into this DPM instance one disk that's 200 gigs in size. That 200 gigs is currently being used to the tune of about 41 gigs. Now, that's not actual consumption at this point. That's just reserved or allocated consumption that a protection group has created in order to support backing up a specific host. You'll find that DPM actually consumes a pretty decent amount of space. And DPM is really intended for, its primary focus is on disks, but you can also use it with tape drives as well. And in fact, if you scroll down here on the bottom, you can see tape libraries and whatever plugged in connected tape libraries that you may have. We're for this nugget, we're only going to focus in on the disk side of DPM. The idea with DPM is that there are going to be some resources that you need to back up or to protect in a short-term way, and then there are others that you need to back up in a long-term way. So our short-term backups here are the ones that are going to be attached to disk. And then our long-term backups, the ones that are kind of the next step in the process, these long-term backups are the ones that will eventually get archived off to tape. So our original systems here, if this is just our Hyper-V host, for example, or really any host, are going to go through generally a multi-step process to get data into whatever format you need. The first hop is, again, to disk, and the second hop here is to long-term storage or for archival. This double hop approach allows you the flexibility of having very short RTO and RPO for the kinds of problems that occur in the short term. Right? Stan in accounting lost his accounting spreadsheet, and so Stan needs to go and recover that spreadsheet. Usually Stan figures it out within, a week or so. Well, if that's the case, you can also make available the tools so that Stan can even recover his spreadsheet on his own, these self-service recovery tools. And we won't get back to that level of depth here, but DPM provides that capability. If he loses his spreadsheet and doesn't actually realize it for an extended period of time, maybe more than 5 days, maybe a week or 2 weeks or a month later, well, generally that spreadsheet is probably going to be found here in long-term storage. And anytime you go down to tape, there's more activities that are involved, right? The tape has to be loaded into the machine. The robot has to grab it. There's a fast forwarding process to get to the right location. And then the contents have to be restored back onto whatever server that data actually was originally on. So this process gives us all the flexibility of what we need for the long term and what we need for the short term by focusing specifically on the types of media that make sense for each of these particular use cases. So here I have my disk, and as you'll see here, I also have one agent that has actually been installed onto a computer. And if I take a look up here under protection, we can see that that agent has been installed onto the computer as cvmm.company.pri. And in fact, what I've done here is not because I sort of lack the storage space. With 14 concurrently running VMs at this point, we're running out of disk space here in this environment. Instead of backing up the entire machine, I've backed up the system state, which is, as you can imagine, just a very small amount of data, and then also just the virtual manager database here right out of SQL. There are really no agents that we need to focus on here with DPM because the agents are handled in most cases by the application. In our case here with VMM, VMM actually leverages the use of the volume shadow copy service in order to support what it's doing. And VSS, if you haven't really played with VSS, actually is 3 separate kind of sub-services in one. On one side is going to be the VSS requester. And the VSS requester is effectively your backup program. You know, a Windows virtual machine that exists in VMware will generally have the VMware tools as its requester. Here in the Microsoft world, it's the Hyper-V integration components. And DPM will actually work with its agents on the system and also the integration components in order to support kicking off the backup here on the side of the requester. On the other side of VSS is the VSS writer. And there can be a number of writers on any individual system. So for example, in the case of SQL, we can have a SQL writer, and the SQL installation will register a writer when you go about installing SQL. The third piece down here is the VSS provider. And the provider, its job is to interface with whatever the disk is to handle the snapshots, to handle creating a system state backup and creating all the necessary pieces so that we can get the content actually backed up onto disk. And so these 3 pieces here actually work hand in hand in order to support this backup. What happens generally is that when you go to kick off a backup, you start by making a request. That request then notifies the writer that a backup is about to happen, allowing installed applications like SQL or Active Directory or Exchange, allowing these installed applications, if I can spell Exchange here, Exchange, to perform whatever pre-backup, during backup, and post-backup activities are required. The writer and the requester then work hand in hand with the provider to ensure that the backup happens in the way that's supposed to. So VSS is a portion of what we're doing here. There is also, as you can see, an agent that's installed from VMM to handle some of the extra activities. But generally, that's what we're doing here with DPM, and why you don't really have to, like you did in the old days, focus so much on backup agents for each of the applications that you have. When you create a backup or a protection group here, you're going to create an initial protection group, and with the replica that gets created, the replica of the data that gets created, and then individually or incrementally at a specific period of time, and you can set these up when you create new protection groups, those additional incremental backups will be added into the initial replica that gets created. Now, generally, your replica is your initial backup, and it's the largest piece of the backup. Occasionally, as you can see here, that replica will actually become inconsistent for one reason or another. When that happens, you can actually go up and verify the consistency of the replica by running just a quick consistency check on that replica. I'm not going to do it at this point because that process can take an extended period of time, but DPM does have the logic built into it that when a replica does come out of consistency, that you can go through and ensure that everything is back into the way that it needs to be. Before you actually get to creating backups, however, one of the first things you have to do is actually go about installing agents onto systems. Now the way we can go about doing that is actually here under Agents, and we can choose to install one or more agents. If we have existing agents, or if we have computers behind firewalls that we need to install agents onto manually, we can accomplish that. There is some extra steps that will be required if you have an agent that needs to be installed via a manual action, and that would involve putting the disk in the drive and completing the connection between these two. If you have machines that aren't behind firewalls or that have the required exceptions that are in the domain, you can actually just install the agents directly here by selecting the top button. Let's actually go ahead and install the agent onto our first two Hyper-V machines. Now these three Hyper-V machines are actually in a cluster. And so you'll notice whenever I click the next button here, actually after I punch in all my information, and we begin the process of checking the machines for consistency, well, we get a little bit of a, not quite an error message, but just a notification that when we are attempting to back up items on a cluster, DPM intends to back up all the nodes of the cluster. Now, if we have an Exchange 2010 DAG, as you can see up here, you don't necessarily need to protect all the DAG nodes. But in a regular cluster, DPM wants to ensure that all members of that cluster are in the protection group. So you'll see here that I need to actually add in Hyper-V 3 as another cluster node into the selected server list. Let's go ahead and install now the agent onto Hyper-V 1, 2, and 3 so we can see how things work. Now, if we have older operating systems, such as Windows Server 2003 or Windows XP, there sometimes is a restart that actually needs to happen in order to install the agent. We have 2008 R2 in this instance, so generally that restart doesn't need to happen. So for now, I'm going to choose to allow the DPM to restart the computers. This is not going to be a big deal. Okay, you'll notice down here actually we get an error message that says that DPM will not restart cluster node service because of the concerns of how this is a cluster and rolling those restarts so that they don't all happen at the same time. I'll choose Next and then Install to begin the process. This installation can occur in the background, so I don't actually need to pay too much attention to it while it's going on. Now the other thing we have to do here is add in disks to support the backup information that we need to store. 200 gigs is not going to get us very far because in order to back up all the needs for our short-term backups for just one machine's system state and one database, as you can see here, well, we already have 41 gigs of used space that's required to support those needs. So let's actually add in some more disks here to support our needs for these hosts. Now, I would start normally by clicking the Add button here, but as you can see, we don't actually have any disks available that we can add to the storage pool. We don't have those disks because DPM disks actually have to exist in a very specific state for them to function here with DPM. We don't actually really format them and create volumes on them. We just make them available and then DPM handles everything else under the covers. Let me flip over here to the actual host SCDPM. So I'm not on the client anymore. I'm actually on that server SCDPM. And as you can see here, what we have is the original 200 gig disk that was created. When that backup, that system state backup, was initially created for this computer, you can see that it actually goes about creating specific partitions on that disk. And these partitions contain the data that DPM is managing for us. Down here, I've actually, via iSCSI, attached an additional 300 gig disk that I need to mount and initialize, but not actually format to make it available for use with DPM. Let me go ahead and right-click here to bring this disk online, and I'm going to initialize it here just as an MBR disk, but that's all that I'm going to do at this point. I can actually, in order for DPM to use it, I do actually need this to be a dynamic disk, but DPM can handle that for me. I don't actually want to go about creating a volume on this disk because DPM does not really work with existing volumes. It needs these to be unallocated disks for it to work. So with this in the state that it's in, I should be able to go back here to the DPM console back on my client, click the Add button, and see that I now have that 300 gigabyte partition, or 300 gigabyte partition without a volume that's now available for adding into the storage pool. Let me choose Add here and click OK. And you'll notice that I have selected basic disks, so it's going to convert them to dynamics. Any existing volumes will be converted to simple volumes here. We don't have any volumes on them, and it's generally a good idea not to put volumes on DPM disks. And you can see now that we have our disk 2 here. So 2 disks are now available. I now have a total of 500 gigs that exists here in this storage pool. If I flip back to the agents, we should see that, yep, it looks like all 3 of our agents have been installed here for Hyper-V 1, 2, and 3. And so our next step really is to go about creating the protection group for our Hyper-V hosts. And before we do that, however, what I want to do is show you one of the options here. There are a variety of options here in DPM, but one of them is one that you may want to pay particular attention to because it's specific to our whole private cloud environment. And that is this notion of auto discovery. Now, auto discovery is something that you have to turn on. It's not necessarily available by default. When you do turn on auto discovery, what it does is, as you can see here, it runs once per day to discover new Windows computers that appear on the network. And what time do you want it to actually run? In a dynamic private cloud environment, this auto discovery is extremely important. If you think about it, if you are creating service requests that link with Orchestrator and VMM to create new virtual machines, well, you also want to ensure that those virtual machines actually get into a protection group so that they don't get forgotten. And a failure end up causing some big major problem on that virtual machine because you were not made aware that that virtual machine now actually exists in the environment. If there are constantly new virtual machines being created and removed, we have to have something like auto discovery to ensure that these new Windows computers can at least be exposed and into the interface so that we can make sure that they get into our protection groups. So pay particular attention here to this auto discovery because, well, it's the one so that your dynamic environment does not come out of sync with your actual environment. So at this point, let's go ahead and now create the protection group that we would have for these Hyper-V hosts. I can do that here under protection. This one I'm going to choose new. I'm going to ignore this inconsistent replica just for now. And when I create a new protection group, this is essentially the group that contains the VMs and also potentially the hosts that I want to protect. Okay, I'm consolidating everything into this protection group. If I choose next here, I'm looking at backing up servers. And I can see all of the hosts now that exist here in Hyper-V 1, 2, and 3. For each of these, I can also back up the resources that exist on the cluster. And as you can see here, I have the hosts, so Hyper-V 1, 2, 3, and I also have the cluster resources that exist. Here's my DB tier 01. There's the Hyper-V information here. Here's backing up using the child partition snapshot, which essentially says back up that virtual machine. So snap that child partition, the virtual machine that exists in Hyper-V, and use that as the source for the backup. I can also go to each Hyper-V host and view the content that exists there. So here's the initial store content as it's associated with Hyper-V for restoring that Hyper-V VM. Here's my system state information and bare metal recovery information for Hyper-V 1. And then if I take a look at all the volumes here, I can drill down into specific information or specific folders there in the C drive or other attached drives that I want to back up. If I select any of these items here, let me just select the system state here because it's a small amount of data to back up. If I select any of these items, I can add those items here to our protection group. Now, when I create our protection group, so let's call this Hyper-V 1 system state. Normally, you would do a much larger amount of information here, but like I said, we're running out of disk space here. Then I could choose whether or not I want to use short-term protection, whether it be a top disk or a top tape. And then whether I want long-term protection specifically using tape. Now, as you can see here, I have to have a tape drive that's attached to this computer for that to function. I don't at this point, so the option is really grayed out. I'm really only interested in showing you the disk-based functions for this because that's really what's interesting in terms of what DPM can provide over a traditional tape-based solution. Now with that, when I've identified what my short-term, that I'm interested in short-term protection, I then have to identify what my short-term goals are. How often or how long do I want to retain data? Okay, if I have a sliding window of data, how wide is that window for what I want to retain before I end up moving things off onto tape? And then when do I actually go about creating my recovery points and my occasional express full backup? This express full backup contains the entirety of the content as opposed to just the specific incremental content. I can adjust this if I want and change it to different times. I can even add additional times for creating those express full backups. I can review my disk allocation and in fact add or not often remove disk space, but I can add disk to support all the disk needs that will be necessary for the data size that I intend to create. Now you'll notice that the replica volume here is going to be larger, as is the recovery point volume, than the actual data size that I anticipate for this machine. And that's because DPM does a calculation to identify how much disk space is going to be required to support your short-term goals and the needs that you've identified up until this point. That calculation sets the replica volume at 15 gigs, the recovery point volume just a touch above 12 gigs here, because that's the anticipated amount of data that's going to be required in order to support those goals. I can automatically grow the volumes in the case that DPM's initial calculations actually did not really jive with how much change is occurring on this disk. That's a good thing to do as long as you have enough disk space to support growing those volumes as the volumes need to grow. If I choose the next button here, I can choose when I want to actually create that initial replica. Do I want to do it now or at some point later, or do I want to actually do it manually if I have, for example, a very large amount of data that may be connected by a very latent network connection. Maybe I have data that exists up in the Azure cloud, and doing that backup now is going to saturate the line between me and Azure. So for large amounts of data, this is I can actually complete that initial replica and do it offline, somewhere out locally to that machine, and then transfer the data through some alternative mechanism. I can also choose consistency check options. You'll see here that we can run a consistency check if a replica becomes inconsistent. We've already seen an example of a replica becoming inconsistent. And then also, do I want to run a daily consistency check according to a specific schedule? Your replicas don't tend to get inconsistent. That's sort of the point behind replicas. But what this is it's there to ensure that your backups are always going to be available for you whenever you have need for them. If I choose next here and then create the group, that'll actually go about creating the group that we intend to create here. Now there is one other setting that I actually skipped over. I want to go back to because I want you to be aware of this setting here under Review Disk Allocation. Because I'm just doing system state and I'm not doing an entire virtual machine or entire computer, I'm not going to actually see this co-locate data in the DPM storage pool as an available checkbox. But when you're actually doing this in production and backing up real virtual machines, DPM has deduplication capabilities that's built into it. And in order for deduplication to really work, you have to have multiple machine instances that exist in the same DPM storage pool. Now, what's deduplication? Deduplication is literally the concept of if I have two files that are exactly the same, well, why create two copies of those files in my storage pool? I'll create one copy of the file and then a pointer for the second copy of the file. Well, in order to support that, I actually have to co-locate the data for multiple machines in that same DPM storage pool. So in a regular backup that involves actual virtual machines, this is something that you would be selecting here in order to reduce the total size of your backups. And if you think about it, the actual amount of data that you're backing up, quite a bit of it is going to be replicated data from other VMs. I mean, every virtual machine or physical computer looks very similar to every other virtual machine or physical computer. So deduplication can really reduce the amount of data that you have to store on those machines. As you can see here now, we have our Hyper-V 1 system state. We're creating the replica at this point. Once the replica gets created, this process takes, because we've just got a very small amount of data, just a very short period of time. Once the replica gets created, well, then we can actually go about recovering that data if we need to. And that happens down here under the Recovery tab. So you'll see here for the recoverable data that we have, we can take a look at our protected SQL instances. We can take a look at Hyper-V if we want here. Here's that original Virtual Manager DB that I created, or that we talked about before we added Hyper-V 1. I've created a backup of this Virtual Manager database. If I wanted to restore this database, I can do so right back onto the original VM, or I could actually restore it to a different location if I want. Now I'm showing you this database because the recovery pieces for SQL are in fact quite a bit more interesting than what you would see for a regular system state. But let's say that I need to recover VMM's database. The way I go about recovering the database is here under the Recovery tab, and if I just choose simply Recover, I can go about recovering any of the available snapshots that I have of that database, either the original replica or any of those that have occurred after that initial replica. Just next here, I can select what's my recovery type. Do I want to recover it to the original instance of SQL? In other words, do I want to overwrite the database? Do I want to recover it to a different instance of SQL, just to a network folder or even a tape if I want to? Do I want to leave the database operational or actually leave the database non-operational but able to restore additional transaction logs? So in the second of these, if there are multiple restores that are going to be required in order to support getting that database up and running, well, I would choose this second option here. Or if I didn't want the database actually running when I completed this restore, giving me the ability to do some extra work after the restore completes, well, I can do that as well. I can leave the database operational here. If I have a SAN-based recovery, if I have hardware snapshots that are set up, I can do that here as well. Also, do I want to adjust my bandwidth usage here so that I don't end up clogging up that network traffic or clogging up that network line between my DPM server and my server that I'm recovering? I can do that here as well. Do I want to send a notification whenever the recovery completes? And then lastly, do I want to actually begin the process? I'm not going to begin this process because I just simply don't want to go through restoring the entire VMM database. But as you can see here, this is really kind of what is available here whenever you're going about doing recoveries inside of Data Protection Manager. You will find that when you create these data protection groups, they give you the ability to back up and recover data over a very fine-tuned period of time. And your RPO can be reduced down to hours if you prefer, or even 15 minutes if you prefer, depending on how often you end up capturing those incrementals. There's one last piece down here, and that's the reporting piece, and built into DPM are just a small set of reports that you can gather that'll let you know what your disk utilization here is, your recovery point status, just a simple status of the system. And these reports, you can schedule them, send them to yourself on a daily basis or however often you need basis to give you more information about the success or failure of DPM. And admittedly, this is just kind of a very basic introduction to Data Protection Manager 2012. Trying to give you some of just the basics that you'll need for passing that MCSC private cloud exam, give you some familiarity with protecting data using DPM 2012. Because DPM, as we say here, is a very simple tool with a very important purpose, that purpose being protecting your virtual machines and also your physical hosts here in your Active Directory environment. So what have we talked about this nugget? We've talked about Data Protection Manager 2012. This is the fourth of our four-part mini-series on the other pieces of System Center. And in this, we actually took a look at preparing the disks, configuring auto-discovery, installing those DPM agents, creating protection groups, and then the backup recovery and reporting tasks here within DPM. We are now going to move on or move away from System Center. We'll still stick with System Center and the management pieces of System Center, but our focus is now going to move on to some of the SP1 functions that are built into System Center. So System Center 2012, the RTM version, is what we've been using up until this point. Well, coming up for the next two videos, next two nuggets, we're going to spend some time taking a look at the SP1 beta, which is now available as at the time of this filming. That SP1 beta gives us some very critical new functionality. It allows us to finally connect up VMM to Windows Server 2012 hosts, so we can take a look at Hyper-V version 3. That's the first of those two nuggets. And then the second, it allows us to connect up our VMM infrastructure, and in fact all of our System Center infrastructure, to both Hyper-V hosts and also at Windows Azure-based hosts up in the public cloud. I think you're going to be very excited for some of the things that you're going to see. But until then, I hope this has been informative for you, and I'd like to thank you for viewing.